Hey everyone, Jason here. Today I'm going to be working on an iPhone 6s that was sent here for no backlight. Now, I have been running into a situation more and more often on the iPhone 6s, so I thought it would be a good time to record a video. Now, I don't care what people tell you about Please Bro solutions. It doesn't matter if you have been in this business for years or if you are just starting out. I think everybody in this business learns to appreciate Please Bro solutions because those solutions are more profitable than things that take you forever to solve. So this starts early on. This board came in a housing, and the first thing I noticed is that the housing has an original cracked screen on it. Now, since it has an original cracked screen on it, the first thing that I start to think is, well, nobody's replaced the screen. It's probably not going to be shorted or blown by a technician. This one's probably shorted just out of the blue. So sure enough, I take the top off of this thing and I look at it, and this one is one that has a classic shorted backlight system, much like the iPhone 6, and I'm going to record a video of me fixing it today so you can see how I've been fixing these. I have been fixing piles and piles and piles of these, so here is your Please Bro solution for a spontaneously shorted iPhone 6s backlight circuit. So as you can see on the iPhone 6s, it's very similar to the iPhone 6. We just sort of have a couple of extra dudes in here. What happens here is sometimes the backlight circuit gets shorted here at either C4022 or C4023, and you wind up in a situation where the two coils and the two diodes are left to take the load, and things fry and bad shit happens. So here's how we check for that. Now, I am completely okay with Please Bro solutions, but it's sort of important to know which solution to apply to a given problem. So you do have to use your brain at least a little bit. So on the iPhone 6s, what I will do a lot of times first of all is I will check FL4211, which it's right in here next to all this stuff. Now, when it's blown, you can see a little bit of black usually, and maybe a solder ball popping out. Like, you can see some hint of FL4211 being blown. We don't really have that on this PCB. That spot looks completely fine. So we don't have any visible damage on FL4211. The next thing that we do is we're going to check and see if we have a short to ground on PPLCM backlight anode. And this one, I already know that we do, but I'm going to go ahead and I'm going to show it to you anyways. So here we go. We've got the meter on the screen, and I'm going to get in here. I'm going to put my black probe on ground, and I'm going to put my red probe here on the middle pin, and we get 1.8 ohms. That's pretty well a dead short to ground, and that's on PPLCM backlight anode. And as you can see in the schematics here, that line is rated for 35 volts. So I'm going to switch you back over to ZXW tool and show you which one that it is. So here's your Please Bro solution. There's not really any need for you to hunt down the cap. Yeah, it could be C4022, but it's just, change it anyway, whatever. It's not. It's C4023. C4023, for some reason, that big old cap just claps together and becomes a steaming pile of garbage, and it don't work no more. So the first thing we're going to do here, we're going to remove the shield from this board, and before we make a curdled up mess here out of the sticker, I am going to put a drop of alcohol on it. I guess you could just let it curl up and get all nasty with hot air. That's fine too. It's not going to hurt anything. I try to send things out as clean as possible because I really I take pride in knowing that I send clean work out the door. I don't send stuff out the door with dirty, nasty flux all over it. There's threads out of a screw hole on this sticker. That's nice. And sure, it doesn't, most of the time, it doesn't make any difference on the functionality of the phone, the cleanliness of it. But just ask your customer. Ask your customer. They may not see it, but they still care. Like, they do care what the inside of their device looks like. Some of the stuff I've been seeing coming from other shops has been pretty freaking nasty. Some of them very, very reputable shops. It's like, oh my God, I can't believe they sent that out the door like that. All right, so we just about got all this goop off of here. There we go. And the only reason I peeled that off was to keep from getting it all screwed up with hot air and and looking bad. I mean, really, it's that I did that only for looks. The next thing we're going to do, we are going to take the shield off of this thing. I have got my hot air set on 390C, and my airflow is set at 40 out of 100%. All right, so let's pull the shield off of this thing. Yeah, there really is no other place, other capacitors that could have shorted, because if any other capacitor in that system would have shorted, it would have blown the filter, because the only other cap is on the outside of that filter. And if we shorted on the outside of the filter, it would have blown the filter. Now, I'm warming this up slow because I don't like to fuck up the sticker. And if you do it slow enough, you can do this without fucking up the sticker. Okay, I feel it starting to give. It's going to drop away any moment. Now, as the board heats up, you can get closer, but if you just get closer and pour all the coals to it all at once, you'll fuck up the sticker. All right, so we've got the shield off of this thing. Let's take you right back in under the microscope, and let's have a look at C whatever, blah, blah, blah. Oh, look, this one's actually visibly fucked. Look at that. A clue. What the hell? Look at this. It's visibly fucked, and the diode's already gone. You know, normally what I get is that this capacitor looks completely normal, but then this diode right here, the one that's missing, is normally raised up off the PCB a little bit. That's normally what I get. Now this one actually has some shit oozing out of the coil over here, so I think we can pretty well safely say that this coil is blown, right? I don't know, that might have just been some goop on top of it. Okay, so here's my experience. Like I said, this is a please bro video. What I've been running into is that the driver's fine. This diode is blown, which... Okay, so the driver's fine, this diode is blown, this capacitor is shorted, and this coil is blown. Now, this diode here is also blown. You can see the little bubble on top of it. And this diode, the one that's still here, is blown, and it's in line with this coil. The diode that's fucking missing, it's in line with this coil. Yet, strangely enough, what I've been finding is that this coil is fine, this coil is blown. So what I've been doing to repair this, I replaced this cap, this diode, and this coil, and have a nice day. Everything works fine. So let's see if that's going to be the case on this one. Okay, so I'm going to put a shield over the CPU here, and I'm using a thin piece of metal and not a coin because I don't like the heat that the coin retains on top of the CPU. Let's get out the parts that we need. We are going to need a 25 volt capacitor, and that is 0603, right? That's going to be this big strip. Yeah, here we go. 25 volts, 10 microfarad, 060. It looks like a 5, but it's really a 3. We're going to need D4021. We're going to need D4020, and then we're also going to need L4020. Okay, I've got, let's see, we've got C4023, D4021, D4020, D4021, and I've got L4020. So let's go ahead and start dissecting this thing. I'm going to switch you back over to the microscope. And we're going to reach a point here. Since we've got this diode removed, we can actually test for whether or not that coil is blown. Let's not make this too please bro-ish. Let me at least show you a little bit behind this. So what I'm going to do here, I'm going to show you how to check to see whether or not this coil here is blown, and so far it never has been for me. I've always been leaving that coil there. So what we're going to do here, we're going to check between one of the legs on D4021 and VCC main, and if we get a really low resistance, then that tells us that this coil is most likely going to be good. So to do that, I'm going to use the XW tool, and we're going to check and see which leg it is that hooks to this coil, and it's actually this left hand leg here. So we're going to check between this leg here and VCC main to see if we get continuity, and to find VCC main, pretty sure we can just kind of poke around here a little bit. Look at that L4040 out here. So we're going to check between here and L4040, right? We're going to put one probe on L4040 And we're going to put the other probe here on this side, and if that coil is good, we should get a very low resistance. We do, we get 1 ohm. So what that tells me is that this coil here is going to be good. This coil here, can we check it? So we got VCC main on this side, and then this side's the leg of that diode. Yeah, we can check it. To check the other coil, we can do VCC main here, and then the same thing, the leg on this other diode. Duh. Sometimes I feel like I'm overlooking things, right? And that coil, like I said, is blown. It don't know what it's going to do. So this coil's blown, this one's not. To repair this, we're going to replace this cap, these 2 diodes, and this coil. All right, let's start taking this apart. We've got all of our components that we need laid right out here. I'm going to start warming this board up, and I'm also going to put a little bit of a shield here on our connectors to keep the connectors from getting singed. I put flux there just so that the people watching this video will think that the flux somehow magically removed these components. Okay, I'm going to start warming this up. The hardest thing for me to remove is this coil, so I'm actually going to go after it first. Okay, we're going to warm this up and soften up the glue here. Now I have no hopes in this coming off the board in one piece because they just hardly ever do. There we go. You realize when it gets to a certain point where the underfill around this thing really starts to get soft. Now I left out the part where you really still verify the problem. On this one I have put this board, you know, it came in a housing and I have powered it on and verified that it was definitively no backlight, because you don't want to start on something like this without knowing that the device starts up and knowing that it behaves. Because if they did make a mistake and they sent you a dead phone that also had a shorted backlight or something crazy, and you go through all this and you fuck up the board, well, that becomes your fault. You know, even if you didn't fuck it up, it's still your fault. You really have to verify this stuff. And, you know, if not for saving your dignity and saving yourself from being blamed, but to be able to solve it when something does go wrong. Because if you didn't verify the problem, and you did something like this and all of a sudden the phone don't boot, you don't know if you caused it, because you didn't know if it started up to begin with. This phone, I know, starts up. Starts up with no backlight. Damn thing. I'll be honest, I am not disappointed that these things spontaneously short. Because this is a very profitable repair. It's not a difficult repair, it's tedious. Now you'll see everything that I'm doing here is with great focus to not fuck up the backlight driver, because I'm trying to save myself the trouble of replacing the backlight driver. I don't want to replace it. And if I accidentally get it too hot and float it, I'll have to replace that driver. This coil there feels a little iffy. I might wind up having all this bragging about only replacing one of the coils. Watch me have to replace that coil anyway. Alright, let's get in there with an iron and start picking away at this glue like I should have been to start with. You really sort of, it's up to you how you wind up doing this stuff. I don't think anybody can, you know, people can sort of give you guidance on like what has worked for them. But as far as how to do this shit and how it's going to work for you, that's all on you. Now, what I did just now is I had a little bit of leaded solder on my tip. I touched this side of that diode first, and then I went to the other side. And I'm using a little bit of hot air here with the iron. And my goal there is to hold the temperature of the board up so that whenever I touch the component with my iron, the pads underneath are instantly at melting point. And it'll come off without having to use, so much hot air and float the driver. Because if I float the driver, I'm going to have to replace the driver. And honestly, on these, I would really just rather not. I guess, you know, I do have them in stock. I've got a strip of new ones in stock, but the driver that's on this phone is perfectly fine. And if I accidentally float the driver, who's to say that I didn't accidentally also float the other guy up here? What is it? That's going to probably be like a strobe driver or something. You know, so if I accidentally float the driver, I'm probably going to be dealing with a strobe driver too. So just, you know, I'm watching my heat. And since I was ranting, I forgot what I done last. I think I added flux. So now I'm going to take me a blob of leaded solder on my 2032 micro pencil here. And I'm going to heat up this area where the cap is. And I'm going to touch the top of the cap ends with this. And I'm going to flood leaded solder down in there. Like that. Do it again over here. Should be good enough. Now, I'm going to move in for the kill. I'm going to go ahead, let's add a little bit more flux. Adding flux while holding the pencil. And I'm going to warm this up a little farther than I did already. And I'm going to put this pencil right up against the side of that cap. And it's going to pop right off like that. There we go. So now we have a cap removed. And I've done it. If you get down and look right next to this solder, next to the IC, I didn't actually really melt it. It's completely fine. Alright, so I'm going to go ahead, I'm going to put more flux down in here on this. And we're going to begin tinning these pads ready to receive new components. And also get anything old out of there. There we go. I was trying to pull a little bit of solder off of that back pad. I tell you what, an autofocus microscope camera right now is higher up on my list than a new soldering station or a hot air station. See, I hardly ever switch irons anymore. I use my micro pencil for almost everything, so I'm not too quick to spend money on a hot air station. Before I spend money on that, I'm going to upgrade my microscope camera. I really am. I am happy to tell you that I spent money on the YouTube channel. I actually bought a computer. This is being recorded on a new desktop. I bought an Intel Core i7 7700K. I bought it in pieces. And I put it together over the weekend with my son. And man, am I glad I spent that money. At first I thought I might have invested money in the wrong place. But now that I've used it for a few days, I know I didn't. I love this thing. Alright, we have solder pretty much everywhere. Now I'm going to go ahead and clean this up with some alcohol. My alcohol container is almost empty, so I'm tipping it up on its side. Trying not to dump it in my lap. So now we can kind of see what we're up against. I'm going to take my blade and sort of pick around at the remaining glue that's around this thing. Yes, I have learned to appreciate Please Bro solutions. Because Please Bro solutions are quick and painless and in and out. I guess if you put some thought behind it though, if you actually check to see if the backlight's shorted, it's not really a Please Bro solution. Okay, I really don't like how much solder has wound up back here. That's a lot of solder on this pin here. And that cooled off fast. Let's just add some flux and use the iron. I don't want to accidentally break that IC because then I've went through all this trouble for nothing. Yeah, when you pull the IC, you know, you risk of pads being lifted and other things. I would just much rather do these without lifting the IC. Okay, so we're not going to nitpick too much here about the underfill left around this thing. I think I'm actually going to stop right there. Let's get a little more solder in here on this diode pad. I'm not going to nitpick, and then I nitpick. Anybody that's been watching this channel for very long knows right as soon as I say I'm not going to nitpick, that's whenever I start nitpicking. So the first component I'm going to put back on the board here, it's going to be the largest component. We're going to put this capacitor back on. Oh, and also, if you would like at this point, you can go ahead with your multimeter. So I'm going to put my black probe on ground, and I'm going to put my red probe on backlight anode, and we will find out that backlight anode is now open. We're at, what, 8 mega ohms, so we no longer have a short. So let's go ahead. We're going to grab us a brand spanking new capacitor here out of our brand spanking new capacitor strips. Big old monster capacitor. That's probably one of the biggest components that I ever work with anymore. That's huge. So we know we have switched the solder here over to leaded, which means that it is going to melt at a far lower temperature. Let go. It's going to melt at a far lower temperature than the lead-free solder around it. So by switching it to leaded, I'm able to sit these components on the board with hot air, and I'm not going to melt the driver next to it. So we're gradually going to warm this up. There we go. Instantly pulling the hot air as soon as that component sits down, because you go too far, you're going to have to replace the driver anyway, and then all of your efforts were for nothing. And for some reason, I don't feel like I've got enough solder on that back pad. I'm going to put a little more on there. Alright, that's going to be fine. Okay, so next we're going to sit our diode in there. And you can see really easy on the bottom which pad's bigger, so orientation is not a problem. And the same deal, as soon as that component goes down, we're going to remove the heat. Okay, we're going to call that done. It don't look straight. Maybe I should flatten it a little, right? We're good. Okay. Now keep in mind, my solder melts a lot easier than the solder that's under this IC next to me. So we're going to go ahead now and we're going to put the next diode on. Okay, and then the last thing we're going to put on is the big bad coil. Okay, so let's get our coil on here. Son of a bitch, get back here. Please, bro, can you please fix my backlight, bro? Go. Same deal, I barely let it melt. Now these, I get a little nervous about the solder on the back, so I tend to flatten them on there pretty good. This one's going to be fine. Now everything I did here was with really dainty motions. So I'm going to peel my board mount off of this thing. Now while the board is really hot is the best time to clean it up. And like I said, I really take pride in sending stuff out clean. So I tend to take more time than most cleaning stuff up, and I tend to nitpick to the point where shit is just ridiculous, and most people are ready to wring my neck, going, motherfucker, just get it, get the repair over with already. Look, he's still wiping it. Everybody's laughing. I don't care. My customers like their shit to be clean. Yes, they do care about what the inside of the phone looks like. If you ask them, would you rather it look like this or look like this? Even if they don't give a shit about what the phone looks like, they're still going to say, that looks nasty. That looks like somebody sneezed and snotted all over the board. That's disgusting. Alright, I think we can pretty well call that good. I've got pretty much all my flux off of there. My components are fairly well nicely installed. There's only so many ways you can chop this shit out of the underfill and not make it look like crap. So, alright, let's pick up our parts. There we go. Now, the last thing I'm going to do here is just to confirm. I'm going to put my black probe on ground, and I'm going to put my red probe on backlight anode, and we get... what is that? I can't see the letter. Oh, we're in the thousands of ohms, whatever. So we have a significant resistance on backlight anode. So my next step from here, we're going to drop this thing into a housing. Let's see, we've got a 6S housing sitting here. There we go. And I'm just going to use a battery. I'm not going to hook it up to a bench supply. The battery that's in this housing is junk. My test housing is thoroughly liquid damaged. So we're going to put this board into my test housing. We're going to hook up the power button. I'm going to leave the dock flex disconnected because I really don't need that. And we are going to hook up our display connector. And then from there, we're going to hook up a battery. We're going to fold the display over and we're going to push the power button. Apple logo. Yay, we fixed it. Not only did we fix it, but I fixed it using a Please Bro solution, which... I'm not going to have to eat out of the trash can. This phone is actually going to leave here fixed today. Yay, how about that? All right, so let's let this thing boot up. I'm going to slide the power off. We're going to put the shield back on it. Okay, so we now have an iPhone 6S with a working backlight. I'm going to push the power button. I'm going to slide to power off, so we have working backlight and working touch. And I'm going to remove the board from this thing. Okay. Let's put the shield back on. So we're going to start heating up the hot air. Now to put the shield back on, I don't use the microscope. I look over the top of it. I line the shield back up on top of the board. And for all of you that are getting ready to troll me for not putting this back on with an iron, I absolutely, positively do not care. Because the way I'm going to put this back on is perfectly safe. The alloy on the shield solder melts so much easier than the alloy they used under the ICs. Maybe they were actually thinking about repair a little bit. Okay, so we're going to gradually warm the board up. Remember, I'm doing this slow because I don't want to fuck up the sticker. And we'll see just as the solder starts to melt. Okay, there's the front down. There's the side down. You know, a lot of this job, it's about dainty, precise control over hot air. Like, I know I'm right on the edge of melting. There, it just melted. Now it's cooling. And I did that so daintily that this side didn't even remelt. and the top's still soldered down. That's it. Our shield is reattached. I don't know if that was in focus or not. So just like the iPhone 6, the iPhone 6s, it's prone to spontaneously shorting in the backlight circuit. And when it happens, so far, I've not ever had it be anything other than C4023. So when an iPhone 6s comes in for a backlight repair, it is either seriously mutilated, its FL4211 is blown, or who knows, or it's due to C4023 being shorted. Now, if it's C4023, the job's quite a bit bigger. You have to replace a coil and 2 diodes along with the shorted cap. But if it is just FL4211, replace the filter and move on. So that's it for this video. I really hope you have successful repairs. I thank you guys for watching. Thanks for clicking like. It's awesome. The comments, you know, I can't respond to all the comments like I said before, but I do read them all, and they help me feel really good and help me to continue producing videos. So keep them coming. Keep them coming, everybody. I will see you next time. Thanks for watching, and have an awesome day.